Just start whenever? Okay, cool. Okay, great. Hi there, everybody. Welcome to the final talk of the day. Thank you so much for sticking around and hearing about this. I've been writing this talk over the past couple of hours because that's how I write talks in a panicked state of fear. And so hopefully it'll be quite lighthearted and we'll go through this and it'll be good. So I'm from CartoDB. I work on the research team there. The research team's composed of a few of us. This talk was actually submitted by Andy, who couldn't be here today, and so he asked me to come and give it in his place. So just to call out the fact that he's awesome and doing stuff. Mammoth is also in the audience. She gave a great talk a couple of days ago about how to do cartography for big data, and we have a number of other people on our team who are doing interesting, cool stuff. I'm going to be talking tomorrow morning about machine learning and kind of an introduction to that and how you can use that in geospatial products. But today I'm talking about something we really love. So at CartoDB we love PostgreSQL. It's fantastic. As everybody in this room knows, it's a great platform. It's really flexible. It's really powerful for geospatial. And our entire platform is really built on it. CartoDB is, bedrock is PostgreSQL, which is great. But we often find a problem with PostgreSQL as well, and it kind of goes like this. You see an amazing map like this one here on somebody's blog, and you're like, cool, yeah, I want to make a map of airplanes and where they go in the world with cool, swishy, giant circles going across the map. And you're like, great, I've got a data set of airplanes, so I'm going to make it. And so you write some SQL, and you're like, I'm going to join with the airlines and the paths, and then I'm going to make a line between the start point and the end point, and that's going to be great. And you do it, and you get a map that looks like this. And you're like, okay, that's good progress. We're starting to get there. We're starting to figure out how to do this. It's fine. It's okay. So what do I need to do? Well, of course, I need to create the great lines, the sort of big circles, the great circles. And so you think, I'm going to segment that line up. I'm going to change it to geometry, and I'm going to sort of interpolate it, and we're going to put it over. And you get some SQL which looks like this. And you're like, okay, this is going to be great. You hit render, your map starts churning away, and you get something that looks like this. And you're like, so close. And what's happening is you're getting this problem where they cross the the zero line of longitudes, and you get it splitting up going back and forward. And so then after about 3 or 4 hours of Googling, you finally come to the solution, which looks like this. And at that point, you're kind of like, really? You're really kind of just like, very much in the Sad Affleck page. And it's a problem. And at that point, you've at least at some point thought about calling Paul Ramsey and asking him how he would do it. This is usually our preferred solution at CartoDB. And that's great. And so we really need a better solution to it. And what we're really seeing here is that there's a complexity to SQL statements that once it gets too far beyond simpler transforms, becomes unmanageable and unmaintainable. And looking at that code example I showed before, you might be able to look at this for a while, figure out what it's doing, modify it, and use it in your own code. But it's problematic. And it's because it's a query language, right? SQL is a query language. It's designed to get you data in and out of the database and to do some light transforms on it. It's not really meant for sort of full-blown programming like this. And so thankfully there's a solution to this. It's called PGSQL, which is a procedural language in SQL, which allows you to write things much more like regular code. You can do things like this. And so looking at this, it's a little bit different from an SQL query. It looks sort of similar. But we can do things like declare variables. We don't have to store everything in CTEs or temporary flag statements. We've got a begin and an end here. We've got a loop in there, so you can actually do iterative things, go through a loop time and time again, and that's great. And we can actually assign variables here. So you don't have to do everything in one go. You can think of it procedurally. You break down the problem into little steps and put them together bit by bit by bit, which is great. And we love the PLPGSQL at CartoDB. We have a whole bunch of custom functions that are written to do interesting things with this language. But there's problems with it as well. It was never really designed to be an all-purpose programming language. And so things like working with arrays is a nightmare. Working with JSON is even more of a nightmare. And it's just kind of problematic. It does let you wrap up really complex functions, like this one here, which is creating a dot density field. So if you give this function a geometry, say a polygon, a number of points you want in there, and the max number of iterations, don't worry about that. It'll place those points randomly within that polygon. So it's basically doing dot density, which is pretty cool. And then you call it just like this. You just say select cdb.densityFast with the geometry, a number from your table, and then it goes off and creates all those points for you, and you make a beautiful map like this, which is pretty cool. You can check this out on our blog if you want to learn how to do it. But as I said before, in PLPGSQL, arrays are kind of weird. JSON's kind of weird. It's a little bit funky. And, you know, it gets a little bit frustrating after a while. Once you start to like ramp up complexity again, it gets to be a little bit harder and harder to do anything with. And, you know, then something will happen, like your friend will text you with his new great badass ASCII art service. And you're like, man, I want an ASCII art service in PostgreSQL. And you're like, maybe I can use PGSQL to do it. And then you're like, but that sucks because I have to write everything from scratch. I have to write the stuff that's going to take the text, that's going to convert it into ASCII art and sort of justify it and everything else. And you're like, I really miss Python. Like, you're just like, I really miss a proper programming language. And in Python, of course, everything's already written. Somebody's already written the module which will like create ASCII art for you. It's all just out there in the world, happily sitting out there. And you know, as executcd, you know, put it, it's great. You can just type import anti-gravity and you can fly, right? So it's like the Python and like other languages are fantastic. And it's really a bummer that we don't have that for PGSQL. So again, we're back to sad affleck. We're just like we're not happy again. Again, thankfully, though, there is a solution to this, which is PL Python, which is a great way of bringing Python into the database, and that's what I want to talk about today. So PL Python is a really great extension to PostgreSQL, which allows you to basically write Python, but execute it from the database, and it's really powerful. So, for example, if you wanted to have a badass ASCII art function, which I wrote earlier today, all we do is tell it what variables it's going to take, in this case text, and then a font, and we see it's returning text, and then we write some Python. And we can import any library that's available on the system. So this little library here, PyFiglet, is a library that does ASCII art. And within 3 lines of code, we return the result. And here's it running on our server. Just like 1 line of code now for the people who are using this at the end. And it creates some badass ASCII art. On CartoDB, that's pretty cool. I installed this on one of our servers, and I used it to generate labels. And so now we have badass ASCII art maps, which is pretty cool. This is a tweet from somebody talking about Tesla Motors from a random data set I had. And we ran one function on it, told CartoDB to display it as a label, and all of a sudden we have this cool extra functionality. And this is awesome. This is really, really awesome. Like, you know, this is a silly example, but there are other libraries out there that are really powerful that we'll talk about later on that are really amazing to bring into the database. So what can you do with this? How does it work? Well, you know, it's the same kind of function as we had before with the PGSQL. We have input statements, various types, and then to return, we can return a table, for example, here, where we just specify that it's going to have 3 columns, 1, 2, and 3, which are all numeric. And then from Python, all we do is return an array of dictionaries, and that basically creates a table in PostgreSQL. So as you see down here, as we run it, we get those 3 columns back. And so it's really easy to pass data back from PL Python to SQL. We can also query the database inside of the function, so we're not limited to just acting on what people pass into us. We can actually access other databases within this. So we get this little object, plpython.execute, and we can run a query in there. That query gets returned as like a dictionary type object, and we can iterate over it and do something like this. So this is a function called access database. And what it does is accesses one of my databases and makes all the text and the body field uppercase and returns it as angry text. So this is an angry textification function. And it's really easy to do that. That's like 3 or 4 lines. It's really nice. And so, of course, like the example I gave before, and those examples are very simple, but really the power of this is it allows us to leverage libraries that have been built and made really powerful for Python within the database. And the 2 of those that we were interested most in at CartoDB are PySAL. Has anybody here used PySAL? Okay, a few people. PySAL is a really great library for doing geospatial statistics. You can do really interesting things with clustering, with geospatial regression, with prediction, Markov chain, spatial stuff, which we'll talk about a little bit here. But it's all in Python. So the workflow we had for a while was to take the data out of Python, take the data out of the database, bring it into Python, run these functions, get the results, and then push the results back to the database. And of course, that's a loop that we don't want our users to have to do. We want to enable the power of this library without that kind of like round loop where you have to have other resources. And so what we're doing is we're building an extension for CartoDB and for PostgreSQL called Crankshaft, which is designed to wrap some of these type of libraries up in a way that's callable from the database. One of the functions in PySAL is called Moran's Eye. It's basically a spatial clustering method. It tells you areas where things are statistically higher than average and statistically lower than average, and things where they're statistically higher than average and surrounded by low areas, and vice versa. So it's a clustering algorithm that tells you where significant regions are in your data. It's really interesting. And so we created this function, which basically is a PL Python function that takes in some details from your call, and then what it does is it imports from this crankshaft library the function that we want to run, it runs that single function and returns. And this is actually a really good workflow that we found to use, because what we can do here is we can update that library, that crankshaft library, without having to recreate the extension on PostgreSQL. So once the extension's in there, it's just ready, it's sitting there, and all we do is we update the Python library, and we have new sort of functions in there, which is great. To give you an idea what this does, this is a chloropleth of people who work from home, and these are the clusters that the function finds. And you just call it with one line of SQL. So it returns those geometries with labels, and you can then use those in your maps. So it's really powerful. Similarly, this is a function for spatial Markov chains. So this is if you've got data which is a time series for each one of your polygons, and you want to predict the next step in that time series. And it uses a spatial version of Markov chains, so it's really accurate. And again, we just wrap it up in a very simple way. It basically just passes in the details, and then we call the function and we return it. So this is an example of calling that function. Just update farmer cluster. Grab the details you want from it and update your table. It's super simple. And these are really powerful algorithms and really powerful methods. I'll skip over this just now. If you want to know more about this, come to my talk tomorrow. I'm going to be talking a lot about different machine learning and predictive stuff, which will be cool. But this is the kind of result map where we're seeing different trends from that spatial Markov clustering technique. So is there any problems with this? There's always gotchas with any method. And with PL Python, it's the same. And the main gotchas are, it's not a trusted language within PostgreSQL, which means that it has access to the system. So if you set it up weirdly and you give anybody the ability to create these functions, they might be able to hijack your system. So there's security concerns. At CartoDB, we get around that by making sure that we write the functions in-house and then just install them on the platform, and they're good to go, and people can use them. But we don't let people write their own functions. The other part is that it's a little bit hard to work with geo, pass geo data back and forth from Python PL and the database. You get geo in as a kind of byte string, and you have to do some work to sort of format that and get it into something that Python can use. So we've tried to shy away from using it too much with geo data. And then there's also the passing of 2Ds arrays hard between SQL and Python, and that's only a problem when you try to make aggregate functions, which have a map and reduce step, and it's really hard to have two-dimensional arrays going from the map to the reduce step. So that's just something to be wary of as well. But apart from that, it's a really good solution for wrapping up really complex Python libraries, bringing them into the database, and really expanding the power of PostgreSQL with Python and the amazing ecosystem of the tools it has out there. And so if anyone has any questions, I'd be happy to answer them. Got 3 minutes for questions? Yeah.
How difficult it is to load the Python extensions into PostgreSQL so they can be used?
Sure. So, I mean, the way that we develop is that we basically just have the extension for PL Python installed. So that's one line, just create extension PL Python, grant for user. And then basically we use copy and paste the text into your SQL terminal, and it's there, and you can use it. If you want to wrap that up in an extension, you do it the exact same way as PL, PGSQL, or any prepared queries, and just load it in. It's really simple. The only thing you need to make sure of is that any libraries that it needs to use are accessible from the system Python on your system. So we have this all running in a Docker container, and all that kind of stuff is segmented off. Yeah?
Are most distributions of Linux already packaging this?
I think most PostgreSQL, when you install it now, it will install Python PL with it, PL Pythons with it, sorry. Certainly most of the package managers will bring down a version of it, or will have a flag to install it along with the version. You have to be a little bit careful about what version of Python you compile it with, so 2.7 or 3. So you can compile it with both of them, but it's a little bit trickier. There's blog posts online that will tell you how to do that, though. It's not too bad. And I think there's a question. Sorry. Yeah.
Just saying the point being that, if you just had it available in your package manager, it would just be a simple install.
Totally. Yeah. It's super easy. Yeah, got it back?
You said you can pass key arrays. Is that right now in the raster from Python?
Oh, I haven't tried anything with raster yet, but maybe you can pass to these arrays in that way. But we found it was really tricky to get it to the way we encountered it was doing ramp reduce jobs where we wanted to contain some idea of state for a number of different geometries. And when we tried to do that, it just wasn't happy with it. I think it's something about the interface between PL Python and PostgreSQL. But if you have a solution for that, I'd love to hear it because it would make our lives a lot easier. But yeah, it doesn't seem like it. Cool. Okay, well, as I say, I'm going to be here tomorrow morning, first thing, probably very tired because I still have to write my other talk. But we'll be talking about machine learning, how we can use some of these libraries to do interesting things in geospatial. It's going to be kind of very much an introduction to machine learning for geospatial stuff, so don't let the machine learning part scare you off, but it should be interesting, and hopefully we can do some cool things. All right, thanks, guys.